Sorry, what? There is a microphone that if you want it to be loud, I'd have to give you, but it can hear you a little bit in the background. Clearly, you've never watched any of my videos. Thanks a lot. So, now that you're big and you're in grade 9, that seems pretty easy. You're like, yeah, okay, hearts and sons, hello, that's not hard. We're doing the exact same thing now. All we're doing is throwing in polynomials. So we're going to be adding and collecting x's and x squareds and m's and numbers. It's the exact same process. We're just stepping it up a little bit. So first thing you should remind of is just the definition of what a like term was. That was one of our vocabulary words. How'd the quiz go today, by the way? Crazy quiz? Really? Okay. Yeah, that might help. Yeah. So like terms have the same, what, two things? Variable and exponent. It's a little like an and, like a and. Put a plus sign. An ampersand? They're called ampersands. And we just want to note the coefficients can be different. That doesn't matter. So first we're going to do it using algetiles, then I'm going to show you without algetiles. So again, if you like algetiles, great. If you don't, great. Not a big deal, it's just two different ways. So we're going to simplify using algetiles, 3x plus 2 minus 5x minus 7. It's exactly what you did in grade 1 and 2 when you sorted stuff and you counted it. It's just now we're throwing in letters. So first thing you want to do is lay out those algetiles. We need 3 x's. What color shape do they need to be? Rectangle, and do they need to be colored or white? Colored. So grab 3 of your colored rectangles. But we like both equally. Yeah, we like both equally. How do I do plus 2? 2 little squares, colored or white? And again, remember mine colored or my white is red. Okay, minus 5x. How do I do minus 5x? 5 rectangles for you, they're white. For me, they're red. And then negative 7 is the little squares.
Oh, wait, so red means white?
Red means white for you, yeah. Again, because sometimes the textbook will use red. Okay, so step number 1 is just laying out the algetiles. Step number 2, now we're going to count, just like we counted the number of suns and counted the number of hearts. The trick with this is what happens if you have a colored bar and a white bar for you? Why do they cancel out? Positive and the negative cancels out. Annika, earphones? So take your positive and your white bar, put them back into your main pile. Well, we have another colored bar and a white bar for you. Put them back in your pile. Take your third colored bar and your other white bar, put them back in the main pile. Well, what about the little squares? How many are going to cancel? 2 of the colored ones with 2 of the white ones. Throw them back into the main pile. And now we're just counting up what's left. So for the notes, what we're going to do is draw it, and then we're going to write it as a polynomial. So what do we have left? So we had a bar that was white. We had a second bar that was white. How many little guys did we have? 5, and they were white or colored. And again, it doesn't matter how you draw them. I could draw them lengthwise. I could put all 5 of those in a row. I could put 2 and 3. Doesn't matter. We're just drawing them. And now we're just naming. So what do I have left? Well, how many x's do I have? And are they positive or negative? So I have negative 2x. And how many 1's do I have? 5. And are they positive or negative? There's my final answer, negative 2x minus 5. That's simplifying. It's just counting and sorting exactly like you did in grade 1, 2, and 3. An expression is simplified once there are no like terms. Okay, once I can't get rid of any more colored and white matching shapes, then I'm simplified. You need to be able to do this with polynomials, because if you can't do this, you can't multiply. If you can't multiply, you can't divide. If you can't divide, you can't do all of Unit 3. If you can't do all of Unit 3, then you're screwed for Unit 4. And if you can't do Units 2, 3, and 4, good luck next year. So that's why we're starting really, really slow and starting with the algetiles and doing lots of examples, because this is the key for everything, is collecting like terms, it's called. It's also called simplifying. It's also called adding and subtracting. It all means the exact same stuff. Okay, let's do the second example. So let's put out our x squared plus x plus 3. Okay, how do I do x squared? Big square, and is it going to be colored or white? How do I show plus x? How do I show plus 3? 3 little guys. The second polynomial is in brackets, and that's not a big deal. I need to do 2x squared, so I'm going to need 2 big squares. Oh, apparently there's a pink square hanging out there. Apparently there's a bunch of big squares hanging out here. Okay, so there's my 2x squared. Minus 5x, what colors? So white for you guys, red for me, 5 of them. And I'm just kind of crowding them in there, right? We're just putting them in a pile. And how do I show minus 4? 4 little red guys, white for you. This is the fun part. Anything that's white and colored and is the same shape, we get rid of. So the green bar for me, or the colored X bar, is going to go with one of the white X bars. The 3 colored little guys are going to cancel with 3 white little guys. How do I know when I'm done? Right, there's no more matching shapes where one is colored and one is white. Can't do anything else. That's called simplified, because I don't have any more like terms. Okay, so let's draw out the answer first. How many big squares do we have? 3 of them. Colored or white? Wait, what? So these are my 3 colors here? How many rectangles do we have? And are they colored or white? White. Again, you can draw them lengthwise, you can draw them widthwise, you could draw them beside, doesn't matter as long as you got 4 white bars in there somewhere. This is when I can usually tell left brains from right brains, because left brain, we like them to be very particular and very neat, and right brains don't care, put them anywhere. It's freeing being a right-brained. What about little guys? How many do I have and what colors? I have 1 little one, and what color? White. So that's the sorting part. That's what you did in grade 1. In grade 2, 3, we bumped out and went, ooh, let's count. Now we're just going to count. How many big rectangles do we have? 3. What does a big rectangle represent? Perfect. I meant square. I just realized I said rectangle, but I meant square. Rectangles, how many do we have? What does it represent? And I have 1 left over, and he's white, so he is -1. Again, we call this adding and subtracting polynomials, or simplifying polynomials, or collecting like terms. It all means the exact same thing, adding and subtracting, collecting like terms, simplifying. It's just counting and sorting from elementary school. What about subtraction? So those ones were addition. Suddenly now we're going to throw a subtraction in there. So we'll talk about it in a second. Let's just lay out our tiles first. So I have 3x plus 2. Get out of here, big squares. Laying out 3 rectangles. 2 little ones. Now I'm just going to make sure that second polynomial is a little bit separate. I don't want to put him right on top of my first one. I want him to be a little bit either beside or further down, whatever. And I need to do an x plus 2. So a big bar, and I need some more little guys. Okay, and I just want to group him separate for a second. So my 3x plus 2 is on the top, and my x plus 2 is on the bottom. Well, when you're subtracting the polynomials, we need to do one thing that's different. Give me a synonym for subtraction. So synonym means same thing, different word. Difference, I like that one. Give me another one. Minus, give me another one. Take away, I love that. Give me another one. Subtract is the same as subtract, yeah. What else? Think outside the box. Negative, give me another one. Opposite was the word I'm looking for, and I grabbed my red pen for a purpose. Opposite. This is why mathematicians, we don't like language, because we just had 6 words to describe this one little symbol. In math, there's just a symbol. This is why words confuse us. A synonym for subtraction is opposite. So the opposite of 3 is minus 3. The opposite of x is minus x. The opposite of minus 2 is plus 2. The opposite of minus x squared is positive x squared. So what I'm going to do is take that second polynomial, the one that followed the subtraction, and we're going to flip it over. We're going to take the opposite, which means flip it over. So you're going to physically flip. I'm going to swap out for red ones. So when you're subtracting, you take the second polynomial, take the opposite, which means flipping it over.
Then do we add it?
Yes, you're just one step ahead of me here. Now we're going to collect the like terms. We're going to group just like we did before. So a colored bar and a white bar, bye-bye. Colored square and a white square, bye-bye. Colored square and a white square, bye-bye. So let's draw what we have left, which I just heard someone say 2x. And so going back to my red pen, the trick with this is you flip the second polynomial. That's how you do subtraction. Okay, number 4 is as hard as they're going to get. 2 trinomials. Okay, don't panic. We just put out the tiles to begin with. So show me x squared plus x plus 3. Just the first one for now. X squared plus x plus 3. You're just laying out the tiles for x squared plus x plus 3. Just the first one for now. Pen clicker needs to stop. You're tactile. Turn to someone in front, behind, beside. Compare your x squared plus x plus 3 to theirs. High five if you have the exact same tiles on your desk. It was the worst high five ever.
Just look at the elbows.
You tell me, what should I have out? So tell me how to lay out the tiles for the first one. One big square. Oh, what? Oh, okay. Okay. Underneath or beside, but keep them separate, lay out the second polynomial that you see, 2x squared minus 5x minus 4. Again, to the side or just down, so don't put it all in the same pile. Keep it separate. Lay out 2x squared minus 5x minus 4. Yep, turn to your partner, high five, you have the same towels on your desk. Somebody high five me? Somebody? Anybody? Now you just have to look carefully at the question and you're looking in between the two polynomials. If you see a subtraction, what's the trick? Flip them over. Again, it's going to take me a little bit longer because I have to put these all back and then take new ones. Bah, not what I wanted to do. And all these go. Ooh, through an x squared. How many little guys should I have? 4? Okay. Now what do we do? Right, start to cancel. So big color square is going to go with big right square. That's it. How do we know that's it? Okay, so let's count them up. Let's draw them out. What do we have? One big square that is white or negative. How many rectangles? And were they colored or white? Why are you confused? We had 1, and then we had 5 that we flipped over, so that would have given us 6 in total. Right, because there's 1 in the first one, and then we would have had -5 in the second, and we flipped them. And how many little squares? 7, and were they white or colored? And now we just count. So what does one big white square represent? And what does 6 colored rectangles represent? And what does 7 colored little squares represent? That's simplifying polynomials or collecting like terms or adding and subtracting. Put the algetiles away. Look around you after you put them away. Make sure there's no little guys sitting on the floor. They tend to spill. It's the little ones that are the sneakiest. We're going to do the exact same thing. We're just going to do it without algetiles this time. So this is called algebraically. What does algebraically mean? It means with algebra. What is algebra? X's and Y's and numbers and polynomials and monomials and binomials.
How did you see the lines of you cutting? If the lines are black.
No, take your time. Sounds like we're not all waiting for you. So I'm going to talk to visual people first, and then I'll talk to the non-visual people after. Visual people, grab a different color pen. What we're going to do is what I call the circle method, and this tends to work for visual people because it pops out the like terms. What I'm going to do is circle 3x and -5x, because those are like terms. How do we know they're like? Well, they have the same exponent and variable, or if we put out the algetiles, they're the exact same shape. Now I'm just going to add them together. If I have 3 of something and I take away 5 of something, I don't care if it's oranges, apples, pencils, video games, dollars, X's. It's all going to be the same. If you had 3 and you took away 5, how many are you left with? Minus 2x. Then I'm going to take the constants, the 2 and the 7, and I'm boxing them because they look different. They're different algetile shapes. They're different terms. And I'm going to put them together. What happens if you have 2 plus 7? Plus 9. Non-visual people, sometimes the circling can be distracting for you because there's a lot going on. Don't feel you need to circle. Sometimes what's helpful for you guys is just to point, and this is also helpful for tactile people. It's just point. This is just like the same shape of algetile. They're the exact same term, and we just combine them. That's doing it algebraically. Number 6, what's the same? More specific than like everything almost. Negative 6m is the same as 8m. Okay, well, whoa, we didn't have m's with algetiles. Well, this is where we can use algebra to branch out from x squareds and x. How do we know those are the same? Because they have the same variable and the same exponent. What else is the same? The 4n and minus 5n. This is the sorting part. This is like where you put the suns together and the hearts together. The counting part comes next. Let's put those m's together. What's minus 6 plus 8? And if you have trouble with doing the integer part, just think of those like algetiles. If you have 6 white and 8 colored, what's going to happen? 2 coloreds are going to be left, which are the positive. What about the ends? We have 4 minus 5. So again, if you're visual, you can pick 4 that are colored, 5 that are white. It doesn't matter what shape they are. Put them together. What do we have left? Minus 1n. And we know we don't need to write the 1 in front. We know a coefficient. If it's 1, it's there, and we just don't need to write it. Well, 7's a question like we did with the algetiles. Let's just do it without this time. I'm going to use the circle method. If you don't like the circles, you can point. Why? Because we had 4 minus 5. So it's like 4 that are colored, 5 that are white. Okay, I have x squared and I have 2x squared. Let's put those together first. If I have 1 of something and 2 more of the exact same something, I don't care what the something is. How many do I have? 3x squareds. Then I have x and I have minus 5x. So 1 minus 5 minus 4x. And again, if you have trouble doing that, you have to picture it. 1 colored bar, 5 white bars. What's going to be left? 4 white, which are the negatives. And then I have plus 3 and minus 4, minus 1. Again, this is called simplifying or collecting like terms or adding and subtracting. They all mean the exact same thing. How do you know when something is simplified? How do we know we're done? Because there's no more like terms in this answer. Is an x squared the same as an x? Well, is a big square the same as a bar? No. Is an x the same as a 1? No. So that's how we know we're done. How are we feeling so far? Thumb up, getting it, kind of getting it, not getting it. Show me where you are in the range. Good. Okay, let's do another one. Again, this is one. I don't know that I'd want to do it with algetiles because you need to put 6 big ones. We're going to have 10 bars over here. Yeah. So by you talking to Matt, you're distracting me. By you distracting me, now everybody else is distracted. Is that fair? So you have now interrupted the learning of 24 other people. Do you need to find a different seat? Okay, this is your last warning because you and Matt are not doing well back there together. Okay, circle the like terms. We have a 6x squared and 2x squared. How do we know those are like terms? Because they'd be the same shapes in algetile. If we had 6 of something and we have 2 more of the something, how many somethings do I have? I have 8x squareds. Okay, the x's, I have 5 and I have minus 10. How many x's do we have? And again, if you're weak in your integers, picture it. What if you had 5 colored somethings and 10 white somethings? How many are going to be left once you cancel? Okay, and then the constants, I have negative 4, and I have plus 3. And again, non-visual people, you might not like the shapes. You can just point to it and do it physically. 5 minus 4 and then plus 3. Again, 4 of white and 3 are colored. We put them together. We're left with minus 1. Take a look at crazy number 9. This is the first time we're seeing monomials with 2 variables. So everything we've done so far had just an m, or just an n, or just an x. Here's our first one with an ab. So the first term is 5ab. The second term is negative 8ba. How do I know those are separate terms? Yes. More specifically, what separates terms in polynomials? The sign in the middle. The order of the variables does not matter. The order of the variables does not matter. Whether I call it AB or I call it BA, it doesn't matter. If I took your name and I switched your first name and last name, as they sometimes do on lists, does that make you a different person? No, it's the exact same with letters. So you want to note, these are like terms. The order of the variables does not matter. Just like people. If I called Haley Green, she's going to look up, which she just did. If she's in the doctor's office and they call Green Haley, she's probably still going to get up and go in. Doesn't matter. It's the same person. So this is still collecting like terms. You have 5 of something and you have negative 8 of something. I don't care what the something is. All we're doing is counting them. If you have 5, negative 8, how many do you have? Negative 3, and now you have a choice. You can call it AB, you can call it BA, completely up to you. Usually we do alphabetical, but it doesn't matter. Okay, so don't let when there's 2 variables throw you off. Don't let when they're different orders. It's still the exact same thing. We're just adding them together. Four x squared minus 3x. Okay, simplify. So let's circle. X squared, uh-oh. I don't have any other x squareds. Okay, 3, uh-oh. I don't have any other x's. What do we do? So think in terms of algetiles. What would this look like? 4 big squares, and then would they be colored or white? Colored. And we would have 3 white rectangles. What would we do with those? Could we cancel any of them? So this is already simplified. How do you know that? Because there's no like terms. What's a like term? Same variable, same exponent. So this is already simplified. If there was a question like this on a test or a quiz, you can't just leave it blank. If you leave it blank, that's telling me you didn't know what to do with it. So you can put down already simplified. You could put down not possible. You could put down NA, whatever. You just can't leave it blank. Blank tells me you didn't know what to do. So some statement that shows me you understood, this is already simplified. Vlad? 16x minus 3? That we would be able to simplify. Did that answer your question? Okay. Subtraction. Okay. What did we do with the algetiles? Flipped. Okay. What are we getting down? Well, I'm going to put the first one exactly the way I see. I'm going to leave the 7x squared minus the 4x plus 1. That's just like laying out the first tiles. I'm just leaving it what I see. Now, I can't physically flip terms. I'm not going to write the 5 upside down. So what's the equivalent to flipping? It's taking the opposite. So I want you to ignore everything that's outside of those brackets. 5x squared, what's the opposite? Minus 5x squared. 5x, what's the opposite? Minus 5x. Minus 2, what's the opposite? Plus 2. So let's just grab our red pen. What did we do when we don't have the algetiles? we changed the sign of every term in the second polynomial. That's how we do a subtraction. It's the exact same thing as flipping it over. We just change the sign of every single term. Now let's just count. I have a 7x squared and I have a minus 5x squared. If I put those together, how many x squareds do we have? 2x squareds. I have a minus 4x and I have a minus 5x. Again, I don't care it's x's, these are just objects. So if I have minus 4 of something and minus 5 of something, think of the algetiles. If I have 4 that are white and 5 that are white, what do I have? Minus 9x. And then I just have a plus 1 and a plus 2 hanging around. I put those together and we have plus 3. This is called simplifying or collecting like terms or adding and subtracting. It's just like grade 1, 2, and 3 when you sorted stuff and counted stuff. Another subtraction. Write down the first one exactly what you see. Don't change it. Take every term with the second polynomial and change the signs. So minus 3b becomes? Minus 3b becomes? Plus 3b. Plus c becomes? Minus c. Minus 4a equals? Plus 4a. Now we just add. I have 4a and I have 4a at the back. How many a's do we have? 8a. I have 5c and I have minus c. How many c's do we have? I missed a c. I got so excited in there. Minus 3c2. Got so excited. So I had a plus 5c and a minus 3c and a minus 1c. So it's 5 minus 3. 2 minus 1. 1. And how do I write 1c? Just plus c. And then I have lonely 3b that has nobody else that's like him. I want to triangle him, but I missed that. And so what do I do when there's nothing else? Just add them onto the end. I have plus 3b. Show me your thumb so far in the part without algetiles. I'm getting it. I'm kind of getting it. I'm not getting it. Good. Are you ready to try one on your own or not yet? Okay. Try number 13. I'll give you a couple of minutes. I'm feeling like you're ready to talk. What do I do with the first polynomial? Just copy it. What do I do with the polynomial following that subtraction sign? Flip it, so change all the signs. So 4m squared becomes minus 4m squared. Minus 3m becomes plus 3m. 5n becomes minus 5n. Why do we flip the second one? Because it's subtraction. When it's adding, we don't do that. Okay, let's collect the like terms. I got 3m squared and minus 4m squared. M is like x, so just think of like the big squares. If I have 3 colored ones and I have 4 white ones, what's going to be left when I combine? Minus m squared. I have negative 5m and 3m. So that's just like 5 white rectangles and 3 colored rectangles. What's left when I smush them together? Minus 2m. And then I got the n's, so I got 8n and minus 5m, n, so I should say. When you put them together, we have 3n. Who had it? Raise your hand. High five someone with their hand up right now.
Put your hand down.
Last two examples are what we call application questions. So the question doesn't say specifically what you need to do. It's not going to say simplify or collect the like terms. This is one where you got to kind of figure out what's going on. This one says find the missing values. What does it mean? It means fill in those 3 question marks. Sometimes they'll put a question mark, sometimes they'll just put a box. It means you got to figure out what goes there. So all this is using the concepts of what we just learned. We would have had a 4x, we would have combined it with something, and we ended up with a 1x. So we would have had a 4x squared, we would have combined it with something, and we ended up with a 1x squared. Well, do you remember way back in grade 2, they used to try to give you tricky questions like this. They'd be 4 plus box equals 1. Remember those? Yes. Or sometimes they put the minus in. This is the same idea. What do you have to combine with a 4 to end up with a 1? Well, what would you have to combine with 4 rectangles to end up with 1 rectangle? Has to be -3. So the first one is -3x squared. Let's do the same with the x's. I've got -3x. I combined it with something, and I ended up with -9x. So I would have had 3 right rectangles. I would have put something with it, and I ended up with -9 or 9 white rectangles. What did I put with it? So if I have 3 white, and I ended up with 9 white, what would I have had to add to it? 6 white, and what does 6 white represent? -6x. There's the second question mark. Third question mark says I had 2, I added something with it, and I ended up with 8. What did I add to 2 to get 8 plus 6? Oh, you don't have to say plus because it's 6, yeah. Okay, so now when you have a question like that in the homework to tomorrow, there's exactly how we do it. It's just working backwards. Oh, then we like to throw in these questions. Whoa! Find the simplified expression for the perimeter. I'm going to highlight simplified. I'm going to highlight expression. That's one of our vocabulary words. And I'm going to highlight perimeter. Not yet. Later in the unit. What does simplified mean? Lowest terms if it's a fraction. What does it mean in terms of polynomials? So that's what we've been doing all day is simplifying. What does it mean? No like terms. So it means at the end we can't have any like terms hanging around. What's an expression? A group of terms. Just means we got a group of terms at the end. We have a polynomial. What's perimeter? How do you remember it's the outside? Like the city. That's a great way for visual people. Let's think of the perimeter highway. The other way I remember it is within the word perimeter is the word rim. And what does the rim of something mean? The rim of a can. The rim of a volcano. What does that mean? The outside. So if you mix up area and perimeter, remember the word rim. So it just means we're adding up all the sides. So I have an x plus 10 plus an x minus 6 plus a 5x plus 1 plus an 8x minus 3. Is that an expression? Yeah, it's a group of terms and you can't have an equal sign in it. Is that the perimeter? Yeah. Are we done the question? Why not? Because it says simplified. So let's look at our x's first. I have an x and another x and then 5 x's and then 8 x's. Again, these are just like the bars. If you laid out 1 bar and another bar and then 5 bars and then 8 bars. How many in total do we have? Offer of 15. Can someone confirm that? Then we take the constants. I have 10 minus 6 plus 1 minus 3. So let's combine in order. What's 10 minus 6? 4. 4 plus 1? 5. 5 minus 3? Plus 2. There's what the question is asking you for. That is a simplified expression for the perimeter. How do you know it's an expression? Bunch of terms, no equal sign. How do you know it's a simplified expression? No like terms. You can't combine a 15x with a 2. Whew, how you feeling? Good? So today's one of the rare